Hello students, welcome to my classroom. In this video, we are going to talk about the concept of piecewise functions. And this concept is repeated in a lot of math classes that you can see for higher math. We begin teaching it in Algebra 1, but you will see it being repeated in almost every math classroom in your higher years. So I will write down the name of the concept, piecewise functions. All right. So as the name suggests, students, there are little pieces of the function. It cannot be just one simple function with one equation. So this time we could have, one, two, or three maybe equations for a given a single graph. So first we will take care of the definition. So basically piecewise functions are, as the name says, the functions in pieces. Functions in pieces. And basically, you have to study the pieces in order to understand how you would graph the given function. So we will start with an example to understand it better. So how basically they are written, let us understand the notation of writing a piecewise function. So a piecewise function is usually written, it is going to be one function. They are considered one, although they may have 3 to 4 different parts, but they're still considered one function. And then we have a curly bracket like this. Now we will talk about the different pieces. So I'll take the pieces in red, and let us say we have x plus 2, and there's a semicolon right there, and it actually tells us, well, x plus 2 only for all the x values that are less than equal to -1. Then comes up the other piece of the function. Again, we have a semicolon here, which tells us, well, for this piece, what is the condition? X is ranging between -1 and 1. That's the second piece. Now let us look at what is the third piece of this function. X is greater than or equal to 1. So these are the three pieces of the given function. I repeat myself again, we are studying piecewise functions and we are looking at the different pieces of the function. So just to understand it better, this is the first piece of the function, second piece of the function, and third piece of the function. And what we do basically on a graph is we graph them together, and we try to match them, all the three pieces together, so we can have our first piece, second piece, and third piece going as a parabola, because here I have a quadratic function. So I hope I'm making some sense. If you can separate them or cut them out, you'll have three separate pieces. And this goes our first piece, this is our second piece, and this is our third piece. So that's how the writing is really complex, but if you try to study it, it'll make more sense to you. So x plus 2 function will only range between the values x is less than equal to 1 is the one that we will graph. Now, because x is less than equal to 1, students, I will have a closed circle here. And then I'm moving on to -1 and 1. So -1, let us say, is here, and 1 is somewhere here. Then it's ranging from -1 to 1. 0 is here. So I'll have an open circle here. Now x is greater than equal to 1, I'll have a closed circle, and that's how it's moving. So basically equal to, is a closed circle. That means that fence is included with the house, and usually we say the fence is not included with the house, so you cannot stand at the borderline pretty much. All right, with that taken care of, I'll also tell you what are the two main types of piecewise functions. And in algebra level, the two main piece type functions that you will study are going to be your absolute value functions. Which is pretty much, the graph is like this. And the second type of piecewise functions that you will study are going to be the step function. Now, step function is basically you have a graph like this. And you have little steps going here. So if you take a look at it and if you color it all, it looks like a steps that you're following. There's a break at every point in the graph, pretty much like you have a little piece, then you have another piece. All these pieces make up that one function. So with that basic stuff taken care of, students, I would like for you to please keep this in front of you, this function that I wrote here, because we are going to talk about this more in detail as we discuss the piecewise function. So on the next screen here, I'm going to show you actually how to graph the piecewise functions on Desmos. So we will just make it a smaller screen. And as you can see, I have Desmos pulled up here. Now, just to save time, I already graphed the piecewise functions here for you. So we will, hopefully you have the same function in your notebook written down. I'm taking a look at the first function here. You can see in green is y equals x plus 2. And in curly brackets, without any space, we just put our interval notations in curly bracket. Now, what does it mean by interval notation is basically that what values is x taking? Now, x is going to take from infinity to -1 for the green function. So it is stopping at -1, as you can see on the graph. I'll just go ahead and zoom the graph better for you. And if you can see, the green function is ranging from, let me see if I can write on it. All right, so this is going to be our green function. So yes, I can write on it. So as you can see that it's ranging up to -1, from infinity to -1. All right, that's our first function. The cool part about your upcoming AZMerit is that you're provided the Desmos calculator. So use it to your benefit. Desmos will actually graph your piecewise function for you, the whole part. The next part is y equals 1. So the next part is going to be whatever happens from -1 to 1, y is ranging just one single value. And what is that one single value? Plus 1. So it's ranging plus 1 there. It's like a constant function here. All right, let's move on to y equals x squared. That is our third part. So I'll try and change colors here for you. And the third part is y equals x squared is this function. And we are only looking at from 1 to infinity, because as you can see, if I keep on making this function smaller, you'll be able to see that it never stops. Now, how could this be used in real life? You know, in real life, you can say, well, from this point to this, the speed of the body was increasing. Well, then then the body was moving at a constant speed. And then we are looking at a parabola for this function for the given body. So as you can see, you can take a look at this one single